Hello, everyone, and welcome. We are here for GIA's Knowledge Sessions, a series of talks and seminars all about gemology fueled by our decades of research. At GIA, we consider ourselves incredibly fortunate to study and learn from gems, and it's our mission to share our discoveries and learnings about the world. I could not be more excited to start off today's talk. My name is Jadeite Jade. I am the Content Marketing Manager here at GIA. And today I'm joined by not one, but two experts. First is GIA's Holly Gia, the Supervisor of Identification of Colored Stones, and Dr. George Harlow, the Curator of Minerals and Gems at the American Museum of Natural History. Now, before we dive in, just a few housekeeping things. Everyone attending this is automatically muted. If you have a question, please submit it using the Q&A feature on your screen. You'll see this at the bottom. Feel free to ask questions as we go. There will be a Q&A session at the end where Holly and Dr. Harlow will be able to answer questions that you may have. We also would like to inform you that we'll send you a copy of this recording later today, along with a survey that we would really appreciate if you can fill out for us. And with that, let's kick off today's knowledge session. Dr. Harlow.
Welcome, everybody. So my presentation is really about the environments in which jadeite jade forms and also where to go find them. So first, I need to acknowledge my many collaborators. I'm not going to list them, but you can see their names there. They're from many countries, and so that's consistent with jade coming from many places as well. So first, clearly there are two kinds of materials that are called jade. There's nephrite, which is amphibole, and jadeite jade. And I use that term because jadeite is a mineral name, not really a substance name. So when referring to it as jade, I usually call it jadeite jade. So first, the significance of jade owes to its utility that has been known by our ancestors since essentially the late Neolithic. So both types of jades were recognized as being tough materials, and first were used as tools, mainly axes and pounders, and eventually, because some of them were beautiful, they got transformed into cultural objects and objects of high value. So both, as I said, both jades are types of rocks, but they're essentially made of a single mineral and have been used for a long time. So nephrite is tremolite actinolite rock, and jadeite, or as it might be more generally called pyroxene jades, are composed of jadeite, the mineral, sodium aluminum silicate, and there are also now some more calcic-rich versions like omphacite jade, which has mixtures of jadeite and diopside in solid solution. So one of the critical things in terms of understanding where jadeite forms is its density. Jadeite is a dense mineral. If we compare minerals that are made of the same elements, sodium, aluminum, silicon, and oxygen, most have a low density. So quartz is 2.66 grams per cubic centimeter, albite a little bit lower, nepheline about the same, and analcime even lighter, but jadeite is almost 30% more dense than these other minerals. And the answer of what does that mean? It means the jadeite must form at high pressure compared to these other minerals. So in terms of the jadeite paragenesis, or the conditions under which jadeite or jadeitite, which is the rock name, forms on Earth, we know it's composed essentially of jadeite. It is found typically as veins and blocks in what I call serpentinite melange. Serpentinite is the product of hydration of the Earth's mantle, which then gets, when it raises to the surface, we recognize it as the green serpentinite. Some of it is actually gem quality. And the other aspect is that jadeite, or jadeite jade, is associated with terrains, areas on Earth that have recorded high pressure relative to low temperature. So the places where this is found are called blue schist belts. They're former collisional areas. Eclogites and amphibole eclogites are other places where you find jadeite sort of along with them. And these are mostly found in the scars of continental block collisions. And another important factor in terms of sourcing jade is they're almost always associated with lateral faults on the planet, much like the San Andreas in California or the Sigang Fault in Myanmar. So if we actually look at a map where the blue triangles represent blue schist terrains, you can see that they form linear bands, and they represent the former convergence of the tectonic plates on Earth. And then the square blocks with green filling are places where jadeite jade had been found up until about the year 2000. And you can see they're generally associated with these areas of blue triangles. However, if we jump to the present, there are many more jadeite occurrences that have been found, and it's mainly because of research by my colleagues and I in terms of recognizing places where people had misidentified jadeite jade, or at least the rock itself, and have now been properly identified. So let me go back. So if you look at your screen, before, after, before, after. So now we're really dealing with 16 different deposits known worldwide. I wouldn't say that's the end of it, but that's what we know now. And I've highlighted the three most important ones in green, and in fact, two of them are related to one another. There's the Jadeite Tract, or the Jade Tract, in northern Myanmar, formerly known as Burma, and then the Nansiban in the Sigang division of Myanmar, which is about 70 kilometers away, but it's in a different state, and it is distinctly separated. So the rest of them have had material found, which in some cases has been able to be used as cultural jades in the past, or has been tried to be used to make gemological jades in the present. But most of them suffer from a problem of either they're in places that are hard to get to, or they're in places where the government doesn't allow you to do that. For example, in Japan, the Omi Kotakigawa area is basically preserved by the government against exploitation. And some places like the Ketchpel in the Polar Urals only has a field season of about a month, and it's extremely difficult to get to. Many of the places are difficult to get to. So the reality is the only two places where jade is extracted really is in Burma and in Guatemala. So on to the geology. So I mentioned that jade is produced at convergence areas, and convergence is where the oceanic seafloor dives beneath another plate, and in that process, the seafloor is hydrated or has been altered by water, and when that dives down, that water gets released. So, So what happens is the seawater goes and rises up into this area that I'm showing, which is part of the Earth's mantle, which has ultramafic rocks that turn into serpentinite. And when you actually look at jade samples, you typically find, as over here in the lower right, this is a sample of jade from Guatemala, and it is full of aqueous fluid inclusions, which is an indicator that it probably formed from a fluid. So this was one of our earliest interpretations. So if you actually backtrack in terms of what we understand about subduction and convergent margins, we have determined based on phase assemblages that the places where you can see these green ovals are the kinds of places with the conditions that are right to form jadeite, mainly in the upper blue schist region, but sometimes deeper into the eclogite region. So this is where the jadeite has been formed and is presumably being formed. So we have another problem, which is getting it back to the surface. And that really requires the tectonics of our planet, which is one of the great features that we have that produces our mineralogical diversity. So here is an example. So in the lower left-hand part of the screen, this is the purple areas are the serpentinite areas in Guatemala. And there are two different sources of jade down here. You notice they follow a fault, which is this transform fault, which opened up part of the Caribbean. And then if you follow the upper transform fault, in other words, one side is moving, the side's moving to the left and the other side is moving to the right. Here's another source of jade in Cuba, which I have visited. And then there's another source of jade over here in the Rio San Juan complex of the Dominican Republic. So they're all right along these faults, and the faults seem to provide a leakage path whereby the serpentinites can, which are low density compared to the rest of the stuff around them, they tend to diapirically rise to the surface. So how do we actually observe jadeite occurrences? This is an example recorded by Bleek in 1908 of a Tawmaw, what's known as the Tawmaw dike in the Myanmar jade tract. And so you find what looks like a intrusion or essentially a fat vein of the jadeite rock, and it has these other things surrounding it. This and the other things surrounding it seem to tell you something either about what was happening along the fault in which it was probably allowed to intrude, and the adjacent rock. So here is serpentinite on one side and serpentinite on the other side, and you have this albite rock, which is very commonly found with jadeite rock. And below it is a different kind of, it's an alkali amphibole rock, which is pretty much only found in Myanmar. So we have developed a model for trying to understand how the process occurs. So the peridotite, which is the mantle, Earth's mantle, which is above the subducting plate, will fracture because it's being tectonically, it's being deformed, and so it's brittle and tends to break. The fluids from below will tend to go into that fracture because the fracture will actually open up slightly. The water will be absorbed and turned into serpentinite, and in the vein gets left behind jadeite. And if this process continues, which appears to do because we can see evidence in the jades of multiple fracturing and multiple generations of jade in any one source. So you essentially go over here to the right-hand side, where you get essentially series of fractures in the jade itself because it's brittle, it wants to fracture before now the softer serpentinite around it. And so this process seems to continue perhaps thousands and thousands of times. We believe it's associated with actual fracturing, which would mean earthquakes. So maybe earthquakes at depth are actually producing jade. Here is a picture of a sample from that we were able to buy in Myanmar, which I think documents what we were talking about. So the center is the jade vein, and you'll notice that the color here is lavender in color, which is not the most common. It's actually quite a rare variety. Around it is material that was once serpentine or maybe ultramafic rock, which is reacted with the same fluids that produced the jade, but turned it into an amphibole. And the serpentinite, which would be outside, is lost because it's fragile compared to this rock. So the boulder preserves the early formation of the veins. Oops. So that's what's known as primary jadeite, where the jadeite is formed from the fluid directly in a fracture. There are other sources of jade where it looks like the jadeite, the fluid, has actually replaced another rock rather than crystallized directly. And here is a model for that, where there'd be a tectonic block probably of something not unsimilar to the composition of jade itself, and it gets fractured and the fractures get replaced. And in fact, the whole rock may be totally replaced by jade. And that's been, we've called that the replacement type of jade, or R type of jade. Most deposits have a bit of both. Some are demonstrably the primary type, like in Myanmar and Guatemala, and other places, like for example in the Alps, tend to have a lot of the replacement type. So let's go on to these places where you can find jade looking at a geologic map, but keyed into tectonic structures and major bodies. So this is the northern part of Myanmar, and this fault here is this, it's a transform fault. It's the Sagang fault. It's a major fault in Myanmar, much like the San Andreas is in California. And the places where you find rocks that are of high pressure are these stars. And the places where jade has been found are these diamond shapes. You see that they're highly correlated with one another, but the point would be is that the stars and give you a hint of where you might continue to look for jade if it hasn't been found already. So this is like trying to predict things. So in terms of this place up here in the jade tract, I'm actually going to show you pictures from Nansibon, where we went in the year 2000, and I think we were the first Europeans to ever be seen there. So here is a group of workers. Notice they're all in white overalls and covers. They have no pockets. They're not allowed to put anything in their pocket. And they're basically raking through the debris of the serpentinite and are looking for little pieces of jade. And then they stick them in this milk can over here. Here am I holding a block that we were able to purchase on site at the locality. And over on the right-hand side is the town of Nansibon, which is essentially just a jade town. It's the only business there is for harvesting jade. So this is on a different trip that George Rossman and I took. George Rossman is at Caltech. Many of you may know him because he's a gem expert as well. And this is underground in a primary deposit where the white looking material is jadeite and the grayish or blackish material is either serpentinite or altered serpentinite. So the real serpentinite is down at the bottom of the picture. There's these amphibole rocks in here. But one of the things to look at is that the serpentinites are often enriched in chromium. And chromium is the element that gives imperial jade or fetsui its color. And you can see that there's an emerald green corona around this inclusion here, which tells you something about the reactions that are going on that provide the elements that give jade some of its color. So on that same trip, we were able to look at some of the alluvial jade mines. So these are where the sediments around the edge of the serpentinite block have been dug up to try and find the debris that weathered off them in the millions of years since it was brought to the surface. And one of the things that people didn't know for a long time is how extensive the work that it's done there. So there are literally millions of people living in northern Myanmar whose only goal in life is to find jade or supply the people who mine jade or other aspects of that kind of business. And so you can see here, all of these things are very large trucks, and they're being used, and they're excavating this area, which they think has some of the jade in it. And if you look at this from Google Earth, you'll find that it's an amazing amount of excavations up there. Here's the area in central Guatemala. The little white dots are places where we have found jade. Initially, jade was only found right in here. And since our work started, we have now expanded it from over here to up in this upper right-hand corner. And that's more than 200 kilometers of distance. So it's really distributed because it's along a fault. And then we found that there's another area, totally different, totally distinct, down in the southern area. And these are actually two distinct jade deposits. but the point is they're related to one another. So here's the field when I first went to Guatemala in 1984. So this is what a field of jade distribution is. The rest of this is all serpentinite. It's all filled with cactus. The jade appears to have a little potassium in it and lends itself to grazing, so the cows have cleaned it off for us. And here's the biggest block we ever found, which has since been harvested, and it was attempted to be taken to Taiwan, but it didn't get there. Here's another block from another trip in 2004, where they excavated around it, and it was a source of an unusual kind of jade called Jadeite or Jade arco-iris, which would be that's a very colorful kind of jade. Now, moving on to the next area that would be a very important source of jade is the northern polar Urals in Russia. So up here, you can see this is the old boundary of some kind of collision. There, the purple are serpentinites, which is what normally hosts the jade. And here are where jade has been found. Some of the material here is very nice, but again, the working season is less than a month and there's no way to get there. So that's part of the problem. Another area, two areas are the Yenisei River area in the Boris Mountains of Caucasia and Russia. Here again, the high pressure rocks, and here's where the jade has been found so far, but obviously more possibilities there. Here in Kazakhstan, in Itmarundi, there some of the high pressure rocks, again with its stars, and here is the source of the jade. And you can see a lot of fracturing going on here. So there is potential to find jade in these areas. The problem is they're not easy to get to. There's not much in the way of roads and stuff in the area. So here's a complete map of the world, basically color-coded by geological terrains of different ages. Most of the things that we find are relatively young in this blue belt and the Circum-Pacific belt. The oldest material is up here in the polar Urals. There's another area in Japan, but as I said before, the Japanese material is highly restricted to be utilized. And then our area in northern Myanmar. There are a few other areas here. Here's one in the Cyclades of Greece, which I've actually visited and appears to have been very important in the late Neolithic and the early classical periods for cultural jades. So the summary is jadeite is formed where plates collide, although it is rarely preserved, and part of that has to do both with weathering, that material disappears, and the other is that you have to have the material brought from depth, perhaps as deep as 70 kilometers up to the surface. Jadeite crystallizes from water. That's something that most people didn't expect, but it appears to be consistent with experimental work that has been done. And the final thing is that whereas jadeite had been very rare, except for only being known in these two places, we have found many more places in the last 20 years. So I would say the prospects of finding more is very good. So here's the end of our field trip, where we relaxed at the pool at the motel we were staying in Guatemala and celebrating each other with a drink. So now for Holly.
Thank you so much, Dr. Harlow. So now we are going to move on to the identification and the treatments in jadeite. So traditionally, the term jade refers to two types of mineral aggregates. That's Jadeite jade and the nephrite jade. But besides these two minerals, some other types of materials could also be sold as jade in the market. So to identify these jade similants, we will have to not only look into their physical properties or the appearance, but also have to rely on some more advanced testing methods. So both jadeite and nephrite are silicates, but they're completely different minerals. So nephrite is not exactly a mineralogical term. It is an amphibole of varying composition in the tremolite to actinolite series. So that is rich in calcium and magnesium and iron. So tremolite or actinolite, they tend to grow into more elongated crystals. So only when their crystals interweave to a very compact felted interlocking structure, they will then be called a nephrite jade. Sometimes tremolite or actinolite could also form in more coarse fiber structure that create this chatoyancy effect. So in those cases, they will be called a cat's eye instead of a jade because their structure is not really compact or tough enough as the nephrite jade. So in nephrite, the most sought after color would be white, while there are also green, yellow, black, and other colors that could overlap with the color range of jadeite jade. Well, jadeite is a pyroxene group mineral that is rich in sodium and aluminum. So in comparison to nephrite, the physical properties of jadeite, like its refractive index, the specific gravity, and hardness, all tend to be slightly higher. So these two types of jades can be easily separated based on their basic gemological testing. And even from the appearance, with enough experience, it's also possible to tell some differences. For example, the green nephrite, they're usually colored by iron. So their color can hardly rival this type of a vivid green color in jadeite that induced by chromium. And also the transparency of nephrite tend to be lower than those of top quality semi-transparent jadeite. So as mentioned, jadeite is a pyroxene group mineral. So pyroxene is a very large mineral group. And besides jadeite, some other gemstones like diopside, kunzite, or hedenite also belong to the pyroxene family. So here we have the general chemical formula of pyroxene, and the letter T here represents for the T site, and that is the tetrahedral site in the crystal structure that is usually occupied by silica. So the common structure of these pyroxene group mineral is actually consisting of these single chains of silica tetrahedral. As for the other cations in the crystal structure, they usually occupy the X site or Y site, that is the octahedral site. And as you can see, there are quite a number of different elements for both X site and Y site. So the various combinations of these elements actually correspond to 20 different mineral species. And what we will look into today would be the sodium and calcium-rich pyroxenes. Well, this ternary graph is showing the classification for some of the sodium and calcium-rich pyroxenes. As you can see, jadeite at this top left corner, it's an end member that's rich in sodium and aluminum. At the bottom end, we have the diopside and augite that both rich in calcium. So the mineral called omphacite is actually a solid solution of the jadeite and the calcium pyroxenes. So basically it contains more calcium than jadeite at its X site. And another pyroxene mineral called cosmochlor, although it's not shown in this graph, it's also a solid solution with jadeite, and it contains more chromium than jadeite at its Y site. So both omphacite and cosmochlor could coexist with jadeite in the jadeite jade, or they could also be the primary mineral of a rock, and their appearance can really resemble the jadeite jade. Now you can all take a guess which ones on the screen are jadeite jade. Well, the answer is actually none. So all the pieces showing here are actually consisting primarily of omphacite. And the typical color of omphacite would be really dark green, sometimes even close to black. However, it's really not uncommon to see some chrome colored omphacite. and their appearance can really reach those of top quality, fine quality jadeite. The texture or the structure of ophsite could range from coarse granular structure to a very fine texture. So generally speaking, if we compare them against jadeite, then ophsite tend to have a more granular structure, whereas the typical interlocking fiber structure of jadeite is just less common in ophsite. However, in those fine quality jade, it's always hard to tell the difference. And the refractive index of ophsite could be slightly higher than jadeite sometimes, although most of the time they would be just the same at 1.66. And in the spectroscope, ophsite could also show the 437 nanometer line that is diagnostic for the Jadeite jade. And if it contains chromium, it may also show the chromes line. So basically, ophsite can have the exact same spectrum as the Jadeite jade. So now you can probably see the limitation of traditional gemological testing. Apparently, it doesn't help so much in separating ophsite from the jadeite. So even though ophsite has already been recognized as a distinct mineral for a very long time, it's really not until the most recent decade that we really start to differentiate them from the jadeite jade in the gem industry. Nowadays, these two very similar minerals can be accurately separated based on some spectroscopic or chemical analysis. For example, the Raman spectroscopy is one of the important technologies used in GIA labs for jade testing. So Raman spectroscopy basically provides some detailed information of the molecular structure of a different material. So it can help to identify different mineral species accurately and non-destructively. As we've mentioned, jadeite and ophsite has quite similar chemical structure. So you may also see some similarities in the Raman spectrum. But still, by carefully comparing each peak position, these two minerals can be accurately separated. Well, sometimes jadeite and ophsite can occur in the same piece of jade. So actually, the intergrowth of jadeite and ophsite is quite common in nature. And a lot of the jadeite jade could contain a small amount of ophsite, and they could also be colored by ophsite to some degree. Like in this pendant, the white area is jadeite, and the deep green area is identified as ophsite. So jadeite can also coexist with many other types of minerals, as Dr. Harlow has mentioned. So if a rock contains too much additional components other than jadeite, then it should not be considered as a jadeite jade anymore. For example, albite is a type of feldspar. It's a very common accessory mineral in jadeite. So when feldspar becomes the primary mineral of a rock, the property of that rock would be quite different from jadeite jade. So in those cases, it would be just more proper to say that's a rock consisting of jadeite and feldspar. The bicolored bangle here is another good example. So the lighter colored area is jadeite, whilst a deep green area is identified as a type of amphibole. As you can see, the amphibole takes up nearly half of this piece. So again, this would be more of a rock. Well, here we have another intriguing example of rock consisting of jadeite and an amphibole. So what's interesting about this piece is that this bead contains both jadeite phase that the showing on the right image. It's a lighter colored region. And it also have an amphibole phase that displaying this cat's eye effect created by parallel fibers. And also worth to mention is that the amphibole that associated with jadeite are not the nephrite, but there are other types of amphiboles, mostly rich in sodium. such as the ridgerite. And they sometimes can be also manufactured into gemstones and really resemble the jadeite and nephrite, but they are not considered as a jade. Well, another pyroxene-bearing rock is macici. So the typical appearance of a macici is very deep green, mottled with black spots and the streaks, and their transparency tend to be quite low. A lot of time, they are nearly opaque. So the mineral composition of macici can be quite complicated and varies a lot. Most of the time, they contains a fairly amount of cosmochlor, and along with other minerals like jadeite, sometimes naturalite, feldspar, or chromite. So their physical properties can also vary a lot, largely depending on its mineral composition. So macici is not really considered as a jade in most part of the world, and it is more like a jadeite simulant. Well, apart from all the pyroxene-bearing rocks we've mentioned, a lot of the simulants of jade in the market now are completely different minerals. For example, serpentine is the type of metamorphic rock that usually come in yellowish green or brown color. Actually, serpentine have been carved into artifacts long before jadeite became popular. But as you can see, its luster and density is not really comparable to the jades. Quartzite is also another common simulant of the jades. Natural quartzite usually come in yellow, light yellow, white color, sometimes green, but it can also be dyed to different colors to imitate the jadeite. Also, the aggregate of hydroglycer garnet may also be sold as jade in the market, and they could really resemble jadeite. Sometimes they're sold under the name the African jade. Well, regarding the nomenclature of jade, there are always discussion going on internationally. And as for GIA, an update was made in the year 2012, and since then, apart from the Jadeite jade and nephrite jade, we have also included the green omphacite as a type of jade when it shows the similar properties and the appearance as the jadeite. So in Chinese, there is a term called fei cui that has been used for stones, the jades from Burma since around 18th century. So the original meaning of this term is a type of kingfisher bird with both red and blue-green feathers. So this word is actually composing of two characters. The fei means red and the cui means blue-green. So in a very long period of time, fei cui has been used primarily for jadeite jade until people start to realize that some of the so-called fei cui are actually consisting of other types of pyroxene minerals. So nowadays, the definition for fei cui has been broadened to also include the rocks that consisting primarily of omphacite or cosmochlor. However, this term hasn't really been widely used outside China. So next we will move on to the treatments in jadeite. So many of you may have heard of the term A jade, B jade, or C jade. So using ABC to describe different types of treatments in jade has been especially popular in jade trading or in Asian markets. So the A jade refers to stones that are completely natural or has been waxed. And the B jade means the stone has been bleached and the polymer impregnated. C means the stone has been dyed. And the first item here is an example of stone being both bleached, impregnated, and dyed, known as the B plus C jade. Well, first, let's look at the waxing. So waxing is not really a treatment. It is more like a finishing process for jadeite as well as many other types of translucent gemstones. So a lot of jadeite will go through this waxing process after it's being polished or carved. So all the wax can cover the surface peat and fractures and give the stone a more bright look. Usually, the presence of minor wax on the surface won't really affect the value of the stone, and that stone will still be considered as an A jade. Impregnation is perhaps the more common treatment in jadeite. So this treatment actually involves two steps. The first is bleaching, and then second step is impregnation. So firstly, the stone will be immersed in the hot acid so that acid will bleach out all the oxidation stain and the impurities in jadeite. And after that, the stone may become quite porous or brittle. So in the second step, those open fractures will be then filled with polymer. This stabilizes the stone and also improve the luster and transparency of the stone. And also, as you can see in the before and after image, because the brownish oxidation stain has been removed, the green color also appear more vivid. Sometimes these polymer-filled fracture could be visible under magnification. Because the polymer is softer than the jadeite, it tends to be grounded down over time and leave this kind of grooves or the so-called orange peel effect on the surface. And however, this feature is not always seen in BJs, especially in the newly polished materials. So the UV fluorescence could sometimes provide evidence of the treatment. Natural jadeite are usually inert under the UV light, which means they don't have any fluorescence, whereas the polymer may sometimes produce strong blue or yellow-orange, yellow-green fluorescence. However, nowadays, more and more BJ doesn't have any UV reaction. So the absence of these UV fluorescence does not necessarily prove a stone as natural. So to identify the treatment, the impregnation in jadeite, most gemological labs will rely on the FTR spectrum to detect the fillers. So if we compare the natural jadeite against the polymer impregnated one, we are focusing on the 2,800 to the 3,000 wave number region. And this is where all the vibration bands of the organic fillers may occur. So in natural jadeite, this region will be clear, whereas any polymer or wax in the stone may induce some sharp peaks in this region. And also by looking at these FTR features, we can tell whether a stone has been waxed or it is being polymer impregnated. Well, jadeite could also be dyed to different colors, and that would be the C jade. And a lot of the time, the dye is added to the polymer filler, and that will be the B plus C jade. Nowadays, B plus C jade is much more common than pure C jade. So in some dyed material, you can see these dye concentrations along the green boundaries under the magnification. And in natural jadeite, the natural green veins are usually associated with green jadeite crystals or some other minerals like we mentioned earlier. So in magnification, they may appear more diffused. Well, the UV spectrum could also provide some evidence for chrome-dyed jadeite. The natural chrome-colored jadeite will show a spectrum that's quite similar to an emerald spectrum with broad band in the yellow-orange and blue-violet region. And there could also be chrome lines in the red to yellow region. And in chrome-dyed samples, their UV spectrum will show strong dye band in the yellow to orange region, and there will be no chrome lines. So all these features may also be easily observed with the handheld spectroscope. Well, jadeite could also be partially dyed to mimic the mottled green color. So some of the so-called blue floating flower or green floating flower could also be dyed. And GIA's lab have encountered this type of a sample that contains both dyed green patches and some natural green veins, like shown in this fluorescence image. All the green patches that associated with strong fluorescence are dyed, whereas there is a small area circled here. It's actually proven to be natural green color. And it doesn't show any fluorescence under the UV light. Well, lavender jadeite could also be dyed. Some of the organic purple dye may show strong orange fluorescence under the UV light, and their UVB spectrum may also differ from those of a natural manganese-colored lavender jadeite. And sometimes the purple dye concentration along green boundary can be seen under magnification. However, some of the dyed lavender jadeite doesn't show these obvious features. So identifying some of the dyed lavender jadeite remains a challenge for gemologists. Well, jadeite could also be coated to improve its surface luster. Sometimes color coating may be applied to improve its color. The coating materials are usually polymer and they could peel off over time, so you can observe them under the magnification. Usually coating is quite easy to detect with the routine spectroscopic testing like Raman or FTR. However, in some mounted jadeite jewelries, the coating may be hidden by the metal. Like in this pendant, the green coating on the back is showing this strong fluorescence under the UV light. However, you can see there is an area in the center that doesn't give any reaction. So that area, it's actually, there's no coating there, which makes it quite difficult to detect detect that coating from the opening from the back. So cases like this can be quite deceptive because the green coating at the back of the jadeite could affect the face-up color of the jadeite. Jadeite may also be heat treated. So heat treatment can be applied to jadeite that contains some iron inclusion. So by changing the iron valence state from 2+ to 3+, it can develop some orange to red color. And heat treatment is very stable. And because it doesn't involve any foreign material or the change of the crystal structure, so this treatment is not really detectable. Lastly, there are also assemblages like doublets of jadeite and other material or triplets of jadeite layers joined by color cement. Sometimes even carving could be assembled. Like this carving is actually assembled as an assemblage of hollowed out jadeite and some polymer. So from the magnified image, you can see there's a very thin layers of green jadeite on top, and underneath it, that's colorless polymer. So after mounting, especially in close back mounting, this kind of assemblage can be quite convincing. Well, the GIA identification report can provide some important information of the gemstone, such as its species, whether it's natural or synthetic, and the treatments. As for jadeite, all these treatments and the detectable treatments we've mentioned today could be shown on the report. And also for the chrome-colored green jadeite, if it's proven to be a natural stone without any treatment, the report may also state it as known in the trade as A-jade. Well, jadeite is such a special and sophisticated gemstone, so our webinar today won't be able to cover all the information about jadeite. So for some of you that may want to learn more about jadeite, here I would like to introduce this fascinating new collection in GIA's Richard Lydical, the Gemological Library, and that is the Bishop Collection, Investigation and Studies in Jade by George Kent. So this work documents Heber Reginald Bishop's massive private collection of jade and includes research articles on every aspect of jade written by 28 specialists. It took over 3 years to produce this elephant volume, and there were only 100 sets made for a total cost of $100,000 US, which is equivalent to nearly $3 million today. So these two leather-bound volumes contain numerous plates, watercolor drawings, colored lithographs, copper engravings, and woodcuts. All is printed in American handmade paper, and the combined weight of both volumes is over 100 pounds. Also, I'm glad to see that the digital version of this work will be shared with the public online through the Internet Archive. Okay, now we come to the Q&A session, and I'll pass it back to Natalie.
All right, Holly, Dr. Harlow, thanks so much. That was a great talk. I know I learned quite a bit, and we've got questions coming in as we speak. The first question is for you, Dr. Harlow. We've got quite a few gemstone and jewelry enthusiasts, and it's my understanding that the museum has some new exhibits that have recently been renovated. Can you tell us a little bit about what our viewers could expect when they get the chance to visit?
Well, it'll be, if anybody is used to the old hall, it was a little bit like going underground, and it was actually designed by Vince Manson, who used to be the director of dreams at GIA. And it's now totally open. It's a typical hall at the museum. A lot of vertical cases, more than 5,000 specimens. There's a gem hall, which is much like the old ones, laid out by either gem variety or gem species. And there's also a special gallery, a temporary gallery in there, which right now has a jewelry display called Beautiful Creatures, which is jewelry designed after animals, and also spanning jewelry of 150 years, which is the same age as the museum. So that's going to only be open until September 19th. So if you want to see that, which for jewelry aficionados, it's be an exciting thing to see. Otherwise, the hall is laid out based on mineral paragenesis by the environments in which minerals form, but it deals with a lot of other things. Because of my own experience, there's a separate case on jade. There's a separate case on mogok because of the important stones that come from there, and quite other varieties. So I think it's both a beautiful hall and also a very informationally rich hall.
Great. And where can our viewers find more information? Just on the museum's website?
Yes, the AMNH website is the Allison and Roberto Mignoni Halls of Gems and Minerals.
All right. Well, I know I will be hopefully in line for those exhibits soon, but let's jump into some more questions about jade. The first question we have is, what gives jadeite all of its different colors?
Okay, well, we had, Holly had the slide on this, or I can do it either way. Can we go back to the,
I'm afraid that that slide is not in this this presentation.
It's not?
Yeah.
Oh, if we could go back to mine, we could go back to my presentation. So I don't think, were you viewing? Yeah, I'd have to get control of the screen to show it. Okay. Well, anyway, I can describe it.
Go for it.
So there's white jade is essentially either pure jadeite or pure diopside, but the color of white is due to light scattering on grain boundaries or fluid inclusions. There's a variety called water jade, which is essentially translucent to transparent with very little color. And there, the grain boundaries between the grains is smaller than the wavelengths of light, so you don't get light scattering. Instead, you get a sort of translucence. So as was Holly said, the chromium color is, so chromium substituting for aluminum, which is mean cosmochlor substitution, either in omphacite or jadeite, produces the emerald green color. The lavender color is produced primarily in very pure jade that has manganese content greater than iron. What happens is if iron is in the Y site, it tends to quench the manganese coloring. So manganese has to be somewhat higher, and it's usually not very much, no more than a weight percent or so. There is a blue variety of jadeite, which is found in Guatemala and in Japan. And it is an intervalence charge transfer kind of color between iron and titanium, and often is found more observable in the omphacite varieties than in the jadeite, pure jadeite itself. So those are really the colors due to replacements with other elements. The other thing that, as Holly said, is jadeite can be colored by staining. And so often the highly variegated jades, which are very popular for carving, actually have influxes of either the iron oxides or iron titanium oxides that cause them to be the ochre colors. And then I found in the cases in Myanmar where the boulder conglomerates are very, very thick, there's an infusion of a chlorite coloration into veins in the fractured jadeite blocks that produce a dark green or almost black color.
All right, Holly, anything else to add, or can I move on to the next question?
I would add that the black jades are generally, they're really very, very dark green. It's just that they're so saturated that they look black.
Okay, we've got another question. Can you guys talk to us a little bit about kind of the value factors with jade? We're talking, we've gotten quite a few questions about color, bleaching, treatments. Can you give us a few minutes about what to expect when looking at the value factors?
Holly, do you want to take that?
Well, when we look into the quality of jadeite, we're basically there are a few factors we can look into. First is the color. Definitely for all the color zones, basically color would be the most important value factor. So for example, in green jadeite, the top quality chromium-rich jadeite, so-called impure green, will command a higher market price. And also, lavender jadeite could also be quite valuable. And next would be the transparency. So basically, the higher the transparency is, the better quality it is. Usually when the grain in the jadeite structure, when the jadeite grain is very fine, they tend to show a higher transparency.
Yeah, so one of the things that I've observed from colleagues who are better at the gemology is that you'll take an emerald green cab, you put a light behind it, and if it has a lot of the black spots, which often mean there's little pieces of chromite in them, that lowers the value. Also, a lot of feathery texture tends to lower the value. The more it looks kind of like green glass, the better, the higher the value.
Okay, great. Can you guys talk to us a little bit about fluorescence? We've gotten a few questions about whether jade fluoresces and maybe why that happens.
Well, for natural jadeite or other oxide, they don't fluorescence. Unless there is some additional mineral that may cause fluorescence, then that's another story. But most natural jade pieces won't fluoresce. And the fluorescent one we're showing in the presentation is treated with polymer. So some types of polymer may show strong fluorescence. And that's actually can be a very handy tool to separate some of the impregnated jadeite. And also some of the waxed, some of the jadeite, if it's been waxed, especially for carvings, if the wax trapped into those carving, the grooves on the carving, you might also see some blue fluorescence along those grooves.
I'll just comment, if anybody have seen academic talks, jadeite is notorious for its cathodoluminescence. So on an electron beam, you see all kinds of colors and textures that you otherwise can't see. And I actually have been to a talk by Serena Sorensen where people applauded her slides, which showed the colors of cathodoluminescence in jade.
Oh, that's definitely, I was just talking about the UV fluorescence. If we are talking about general fluorescence or luminescence, then definitely there are, like for cathodoluminescence, some of the jadeite may show strong fluorescence, and we can see the growth pattern of the jadeite under the cathodoluminescence.
All right, fantastic. We've got a question kind of about location. What about jade found in British Columbia? Is that actually nephrite? Can you tell us a little about some other locations outside of Burma and Guatemala, Dr. Harlow?
So I'm unaware of any jadeite jade in BC. Certainly there's some important deposits of nephrite, and some of that nephrite has the imperial green color, and so it is chromium colored. But I think that those deposits, again, are high up in the mountains. They're only available in 2 months a year, and I understand that they're depleted. And so now the material that's replaced it actually comes from Russia mostly. In terms, there's jade in California, of course, but it's never been utilized either archaically or in modern times for gem use. And the other problem with it now is it's also associated with an asbestos deposit on BLM, Bureau of Land Management lands, and so even gaining access to it is very difficult. I mentioned Guatemala. So Guatemala produces a lot of jade. Most of it is not high quality gem jade. There's a black variety from Guatemala that's been sold, which is actually a rock of kerammite and omphacite. There is blue-green jade from Guatemala, which is very rare, but was well known in the archaeological materials. And there's another variety, the Olmec jade, which has little clouds, which are inclusion clusters, usually of albite inside a blue-green matrix jadeite. And we've only found a couple of pieces during our reconnaissance over the last 20 years. So it's just too rare to be commercially produced. And the sources in Cuba and the Rio San Juan of Dominican Republic, they've been used again for artifacts. There were efforts to try and commercialize the material, but the qualities really aren't up to. Burma is really the definition of high quality jade, and no other locality produces anywhere near either the volume or the quality to greatly compete. What has typically happened is the material from Guatemala has been illegally exported and then tried to be sold as Burmese jade. And those kinds of issues, as you can understand with things like rubies, when somebody says you have a Mogark ruby, but it's actually from Africa, that poses a serious problem for people who want the imprimatur of a locality.
All right, let's do one last question. Holly, maybe you can take this. What are the physical characteristics of replacement jade? Can either of you give us a little bit more information?
You mean what replacement of jade?
Oh, the kind I was talking about geologically is, so there's primary jadeite where it forms in a vein, and there was nothing there before. It was a cavity that gets filled with the jadeite. Replacement jade is usually an albitite or a plagio granite, which is an oceanic rock that the fluids that produce jadeite have permeated and partially replaced and produced new jadeite instead. And so that's that replacement jade. In general, it's not it doesn't produce high quality gem material, but it has been used a lot for artifacts or for fashioning axes and things of that sort. So it's more of what I would call the academic interest in archaeology and stone rather than the gemological.
All right, well, I think that concludes our talk for today. I'm sorry we didn't get to everyone's questions, but you can always find us on our social media platforms, Instagram, Facebook, LinkedIn, and Twitter, so you can submit your questions there. And as a reminder, we will be sending out a recording of this talk later today, along with a survey. We'd really appreciate your feedback. And don't forget to look up the museum exhibits that Dr. Harlow mentioned. Thank you so much, Holly and Dr. Harlow. We really appreciate your time.
Thank you. It was a pleasure.
Great talk. And everyone else, thanks for coming and joining us today. Just as a quick reminder, in 2 weeks, we will have another knowledge session with Dr. Chunwei Zhou of GIA, all about gemstones of the sea. We hope to see you there. Thank you.